let's look at another example. Derivative functions, that's what they've given to us, and we have to basically work backwards to find the equation of the original cubic function. All right, so what's been given to us? They gave us this derivative function, there it is, and they've given me the two x-intercepts, there they are, and they're wanting me to find the original f of x function, and they've given it to me in part. They've told me that the constant term at the end there is 12, okay? So remember, that's important because when you're working backwards from the derivative to the original, you wouldn't know what that missing constant term was because it got dropped along the way. Right, so where are we going to start? We have to get that yellow f of x equation, but we're going to have to start, let's just work on the side here, by getting the derivative function. That's what I need to find, the derivative function's equation. And it's a parabola, and because it's a parabola where I've got two x-intercepts, this is my starting point. Okay, oops. Right, so let's see, I'm just going to move over a little bit. So A is x minus -3. That's going to land up being positive a third, and x minus 3, all right? And then we need to use another point. In this case, it's going to be 0 and -3, and we sub that into the other x and y's that we have. So -3 is equal to a. Instead of x, we've got 0. I've got a third, and instead of x again, we've got 0, and that's it. Right, what does that give me as my a value? 3. It works out as your a value. I haven't shown all the working out. You need to do it, okay? Please make sure you don't skip steps. I'm just doing it for getting through everything, okay? Right, so what is the equation? So we put the 3 back into your a. I've got x plus a third. I've got x minus 3, and we FOIL everything out and we times it all out, and we land up with y is equal to 3x squared minus 8x minus 3. Okay, make sure you do that working out so that you understand how you get there. FOIL, that's what I did, and distribution. Okay. Now that we've got that, we have to work backwards to find the original f of x. So we're going to do the rules of differentiation in reverse, okay? So to find my original f of x equation, because in fact, remember this over here represents your derivative equation, we're going to do the rules in reverse. And remember, the rule is we add 1 to our exponent. So we say 3x, and we added 1, so it becomes 3. And then we always divide it by that exponent. If there was a 1 sitting there already, I'm going to add another 1 to it. So therefore it becomes x squared, and I have to divide it by that exponent. If there isn't an x sitting there, if you've just got a constant, do you agree that actually it looks like there's a 3 to the 0 sitting behind it, okay? So we're going to add 1 onto it, so it's going to become minus 3x to the 1, and I divide it by the exponents, okay? So that leaves me with 1x cubed minus 4x squared minus 3x, and that constant term that we wouldn't have known unless they told us is plus 12. If we didn't know what it was and they didn't tell us, we'd have to leave it as a plus c, okay? It's just the normal kind of notation that they give to it. So if they don't give it to you, that's what you want to write at the end of your equation, all right? There we go, all right. Just quickly having a look in terms of the diagram. So remember we said that if I were to sketch this, if I were to sketch the cubic function, we're going to draw a little line passing through the x-axis over the x-intercept there and the x-intercept over there, and we draw a line through the turning point, okay? It's a smiling parabola, which means it's going to be a positive cubic graph. At the one x-intercept and at the other x-intercept is where it will be turning, and at the turning point, it's your point of inflection. So it will look something like this. It's going to increase up to there. It's going to turn and come back down. It's then going to turn at this point and it will increase again. And that point there being your point of inflection is where the graph went from being concave down to becoming concave up. All right, there we go. So if you practice that, those are marks in the bag. You honestly will be able to do that. It's considered difficult, but you just need to know a few facts. So well done and keep practicing. That is the key.